So this is going to be the third video in the series on exponents and polynomials. Okay, so in the first video, we just talked kind of like an overview of what exponential notation is, what exponents are. Second video, we started talking about some of the laws of exponents. We talked about the product rule, the quotient rule, and the power rule. And then we also talked about zero exponents and negative exponents a bit. So what I want to do today is continue with the exponent rules, and we're going to expand it quite a bit and look at how to divide and do some more with multiplication. All right, so let's get started. Okay, so just a quick recap before we get started. Please recall from yesterday, or the video I made yesterday, that we have the product rule. The product rule states that if you multiply two terms with the same base, the result is going to be that same base, and then you add the exponents. So keep the base, add the exponents. All right. We have the quotient rule. And this one says if you're dividing two terms that have the same base, you keep the base and you subtract the exponents. And then finally, yesterday, we talked about the power rule. The power rule said that if you have a term in exponential notation raised to another power, you keep the original base and you multiply the exponents. Okay. Now, we also talked about the zero exponent. Let me see if I can fit those. I guess I'll just do it over here. We talked about the zero exponent. And the zero exponent basically says anything to the zero power is 1. We talked about negative exponents. And you had two situations for negative exponents. You had a to the negative n is equal to 1 over a to the n. And then you had 1 over a to the negative n equals a to the n. Okay, so basically when you're dealing with a negative exponent, what happens is the term that contains the negative exponent changes locations in a fraction. So if you have a term that's just all by itself with a negative exponent, rewrite it as a fraction with that term in the denominator. And then if you have something that already looks like a fraction, something's in the numerator with a negative exponent, it moves to the denominator. If something's in the denominator with a negative exponent, it moves to the numerator. Okay, and once you make that move, the exponent does become positive. Okay, so what we want to talk about today are quotients and powers, or quotients and products raised to powers. So we have first the product to a power rule. Okay, so the product to a power rule basically says if I have a product A times B and I raise it to the power of n, that power goes to every factor in the product. Okay, now this only works if your product is in parentheses, but if you do have a product in parentheses raised to a power, you bring that power to each factor. So this is equal to a to the n times b to the n. So let's talk about how this happens. Let's say that we had 3x squared cubed. Well, that's the same as 3x squared times 3x squared times 3x squared. Since we're just multiplying, we can apply the commutative property of multiplication. The commutative property is the property that allows us to move factors around. Moving factors around won't change your final product, okay? So this is really the same as 3 times 3 times 3 times x squared times x squared times x squared. So now you can see that we had 3 of the 3 factor, we had 3 of the x squared factor. So this is really 3 squared times x, whoops. It's 3 cubed times x squared cubed, or 27x to the 6th. So the cool thing about this rule is we can skip all of this extra work right here. We don't have to do all of this. We can just jump straight here. Okay, so with this rule, you can skip the extra steps. And jump straight to a to the n b to the n. So again, these rules are like shortcuts. They're time savers, okay? So use them. You can certainly expand everything out, but what if in this case, when we had 3x squared, what if I had 3x squared to the 12th power? Would you want to write that out? Probably not. So make sure you understand how these rules work and how they save you time, okay? So now let's just look at bunches and bunches of examples, okay? So let's say that first up, we have 5x to the third squared. Now, I could certainly write this as 5x to the third times 5x to the third. I could rearrange my factors and then I could simplify. Or I could just acknowledge the fact that this power is going to be applied to the 5 and to the x to the third. So this is really 5 squared times x to the third squared. And then I can simplify each term. 5 squared is pretty simple. It's just going to be plain old 25. But then x to the third squared, I have to go back to those rules that I learned yesterday. And we're dealing with a power rule. So we had 5 x to the third quantity squared. So we already dealt with the 5 squared. Now we have x to the third squared. So what I do there is I keep the original base, and then I multiply the exponents. So here I want to take the 3 and the 2. I want to multiply them. So I end up getting 25x to the 6th. And that's my final answer. Okay. So we're going to keep looking at examples, and hopefully the more examples we look at, the easier this will become for you. So let's look at the next one. I have negative 4x to the third quantity cubed. Okay. So this is the same as negative 4 to the third times x to the third raised to the third power. Well, negative 4 to the third, first of all, let's talk about the sign. I've got a negative in parentheses with an odd exponent. That odd exponent tells me my product here is going to be negative. And then 4 to the third tells me what the product is. 4 to the third happens to be 64. So I get negative 64. And then for this right here, I have x to the third raised to the third power. This is a power rule. So I'm going to keep the x and I'm going to multiply the exponents. So I get negative 64 x to the 9th. Okay. So just make sure you understand these rules that we talked about yesterday, the product rule, the quotient rule, and especially the power rule, because the power rule is going to come up quite a bit. Okay. So let's go back and try another one. For this one, let's say that we have 6x squared y to the third power. Well, now I have 3 factors in my product. So that means this exponent of 3 is going to go to the 6, x to the second, and to the y. So I'm going to get 6 to the third times x squared to the third times y to the third. Well, 6 to the third, we want to work that out. And we should get 216. You could certainly use a calculator for that. So I get 216. And then for x squared to the third power, this is a power rule. So I'm going to keep the original base and I'm going to multiply the exponents. And then y to the third doesn't really simplify. We just bring it down. And there you have it. So again, we're just going to keep on working. I've got 3/4 x to the 4th squared. So in this case, the squared part is going to go to the 3/4 and to the x to the 4th. Okay. Now, eons ago, when you first learn about fractions, especially when you're doing like fractions with the order of operations, you'll generally learn how to deal with a fraction raised to a power. So basically what happens here is the 3 is going to get squared and the 4 is going to get squared. And you're going to see this much more in depth in just a minute. We're going to talk about the quotient to a power rule, which is kind of like what we're doing here. Okay, so this is going to be 3 squared over 4 squared times x to the 8. So we just want to simplify it a little bit. We're going to get 9/16 x to the 8th. And that's it. All right, so don't let those fractions flip you out. It's really, truly just a low-level version of what I'm going to show you in a minute. But most people have seen a fraction raised to a power, especially when you're learning the order of operations with fractions. Let's keep going. Let's say I have negative 2 x to the third y to the 4th cubed. Okay. So that exponent of 3 gets applied to all 3 of these terms. So I get -2 cubed, x cubed, cubed, y to the 4th, cubed. Now, for -2 to the 3rd, let's talk about the sign first. You do have a negative inside parentheses. So the exponent is going to tell us if it's positive or negative. Remember, even exponents make for a positive product. Odd exponents make for a negative product. This is assuming that your base is in parentheses, which ours is. So the exponent of 3 is going to make this negative. So I'm going to get -2 to the 3rd, which is 8. Now, for x to the 3rd squared, we're just going to multiply those exponents. So I get x to the 6th. And then the same thing for the y, we're going to multiply those exponents on the y. So we're going to end up finally with xy to the 6th, or let me try that again. We're going to end up finally with -8 x to the 6th, y to the 12th. Okay. Next up, we have -3x squared y z to the 3rd, all of this raised to the 4th power. So this one's a little bit different than what we've looked at so far because we have 4 factors inside parentheses, but the same rules apply. You're just going to bring that exponent inside to each factor of the product. So I get -3 to the 4th, x squared to the 4th, y to the 4th, z to the 3rd to the 4th. Okay. So starting with -3 to the 4th power, we first have to talk about the sign. I do have a negative inside parentheses. So that means the exponent is going to tell me if it's positive or negative. My exponent is even this time, which tells me I'm going to get a positive. So 3 to the 4th is 81. So here we get positive 81. Now, x squared to the 4th, we're just going to multiply those exponents. So I'm going to get x to the 8th. That is an x. It looks kind of stupid. Let me fix it. And then for the y, there's nothing really to combine with the y. We just have plain old y to the 4th, so we bring it down. But then for the z, we're going to take those exponents, 3 and 4. We're going to multiply them. We get z to the 12th. So what I have here is 81, x to the 8th, y to the 4, z to the 12th. So a couple more examples. Let's see what we have next. For the next one, we have 2/3 x squared y to the 4th quantity squared. So I'm going to apply my exponent to all parts of this product. For 2/3 squared, the 2 gets applied to the 2 and the 3. So I'm going to square 2. I'm going to square 3. X squared is x to the 4th. Y 4th squared is y to the 8th. And that's it. Let's do one more. So for this one, I have -2 x to the 3rd, y to the 4th, z to the 8th, all of this raised to the 5th power. So each factor gets raised to the 5th. So I get -2 to the 5th, x to the 3rd, to the 5th, y to the 4th, to the 5th, and z to the 8th, to the 5th. So -2 to the 5th, let's talk about the sign. I've got -2 in parentheses. My exponent is odd. That's going to make this negative. And then 2 to the 5th happens to be 32. X cubed raised to the 5th power is going to be x to the 3 times 5, or x to the 15. Y 4th to the 5th power is going to be y to the 4 times 5, or y to the 20th. And then finally, z to the 8th raised to the 5th power is going to be z to the 8 times 5, or z to the 40th power. So our final answer here is -32, x to the 15th, y to the 20th, z to the 40th. Okay, so that is basically the product to a power rule, but let's see if we can expand it. Okay, so what if I gave you 2 terms to multiply together? So what if I gave you something like 4x to the 3rd times 3x to the 4th? Well, this is a little different because I don't have a single product to a power. I just have a product. So what I would do in a situation like this is I would rearrange all of my factors. We can apply that commutative property of multiplication that allows us to rearrange factors in a product. I would take these coefficients here and here, and I would write those side by side first, and then I would write my x terms. So 4 times 3 is just 12, and then x to the third times x to the fourth, I can go back to that first slide where we talked about the product rule. The product rule happens when you're multiplying two terms that have the same base. So here I have x to the third times x to the fourth. What they have in common is the base of x. So I keep the x and I add the exponents here. 3 plus 4 is 7. So make sure you understand when to use the product rule where you add your exponents versus the power rule where you multiply your exponents, okay? Let's do another one. So for this one, let's say I have negative 5y to the sixth times 6y to the third. So just like in the previous example, I'm going to take those coefficients of negative 5 and 6. I'm going to write those side by side. Then I'm going to write the y terms side by side. Well, negative 5 times 6 is negative 30. And then y to the sixth times y to the third is, again, the product rule. The product rule happens when you're multiplying two separate terms that have the same base. You keep the base and you add those exponents. So I'm going to get 6 plus 3 is 9. So this simplifies to just negative 30 y to the 9th. So what I want to do now is look at two examples that are expanded a little bit more. So it's not just multiplying two terms, it's multiplying two terms where extra exponents are involved. So what if I had negative 2x squared squared times 3x to the third? Well, in a situation like this, what I want to do is I want to take care of this outside exponent first, okay? So that outside exponent is going to come inside to the negative 2 and to the x squared. And then I still have my 3 and my x to the third as that second product or that second factor in this bigger product, okay? So what I want to do now is simplify right here. I want to simplify negative 2 squared. Well, I've got a negative inside parentheses, but I do have an even exponent, so that's going to make this positive. And then 2 squared is just 4. So this is positive 4. And then I'm going to go ahead and write that 3 over here beside it. Now what I want to do is I want to simplify this x term. So I had x squared, quantity squared. So this is the power rule. I have a term in exponential notation raised to an additional power. I keep the initial base and I multiply the exponents. And then don't forget, we still had this x to the third in that other term. So I have 4 times 3, which is 12. And then I have x to the fourth times x to the third, which is the product rule. I'm multiplying two separate terms with the same base. So I keep the base and I add the exponents. So I get 12x to the 7th power. Okay. So next up, I have 4x squared y. That whole product is raised to the third power. And then I have 5x cubed y to the fourth quantity squared. Okay. So in this case, I have two exponents on the outside, and those exponents have to be dealt with first. So for the first term, or the first factor in this product, I have 4 to the third, x squared to the third, y to the third. And then for the second half, I have 5 to the second, x to the third to the second, y to the fourth to the second. So all I have done so far is I have taken those outside exponents and I've brought them into each factor of their product. So now I want to kind of simplify terms. So 4 to the third power is 64. And then x squared to the third power, I'm using the power rule. I've got one term in exponential notation that is raised to a second power. So I keep the base, multiply the exponents. Y to the third, there's nothing to do to it, so I'm just going to bring it down. Next, I have 5 squared, which is 25. And then I'm going to use the power rule to simplify x to the third squared. I keep the initial base and I multiply the exponents. And then finally, I have y to the fourth squared. I keep the initial base of y and I multiply the exponents. Okay. Now, I'm going to rearrange everything. So I'm going to put the coefficients together. I'm going to put the x's together. And then I'm going to put the y's together. And then we'll do our final simplify. So 64 times 25 should give you 1600. X to the sixth times x to the sixth, we're going to use the product rule. We're multiplying two separate terms that have the same base. So I keep the base and I add the exponents. And then the same thing for the y. I'm going to keep the original base of y. I have two separate terms, both with a base of y. So I'm going to keep the y and I'm going to add the exponents. And there you have it. So there we have 1600 x squared y, or x to the 12th, y to the 11th power. And that's it for the power to a product rule. So remember, this was all the power or product to a power rule, okay? What we want to do next is look at the quotient to a power rule. So in the quotient to a power rule, you're going to have some quotient. We'll call it a over b, and it's going to be raised to the n power. This only works if your quotient is in parentheses. And what happens is you just let that exponent go to each part of your quotient. You kind of saw this when we were doing the previous example. We did 3/4, I think, squared. So a lot of times you've already seen the quotient to a power rule. You just don't necessarily know you've seen the quotient to a power rule because you were just dealing with fractions. And a lot of students learn how to deal with a fraction raised to a power when they first learn fractions. So this one should be somewhat review, but we're going to expand it a lot. We're going to add lots of variables and stuff to it to kind of bulk it up a bit. Okay, so let's go ahead and look at some examples. First, I have x over 2 cubed. Well, according to the quotient to a power rule, I can just jump straight to bringing that exponent into each piece of the quotient. Okay, now if that isn't if that's not obvious to you, what you could do is think of this as x over 2 times x over 2 times x over 2. And what that does is that gives us x times x times x over 2 times 2 times 2, or x to the third, 2 to the third, which happens to be x to the third over 8. Now, you can do all of that extra work, but the whole point of these rules is to give you the shortcut. All of this stuff that's in red, you can skip. You can just jump straight to x to the third over 2 to the third, which gives you our final answer of x to the third over 8. So I encourage you to take off those training wheels, stop multiplying everything out, stop expanding everything out, and learn to use these rules as intended. Okay, so let's look at another one. So we're not going to do all the work. We're just going to jump right to it. We have 2 over x to the second. This whole thing is raised to the fourth power. So what this means is I have 2 to the fourth over x squared to the fourth, or 16 over, well, x squared raised to the fourth power is the power rule. So that happens when you have a single term raised to an extra power. So we keep the original base of x and we multiply the exponents. So here we end up with 16 over x to the 8th power. All right, so next up, let's try negative 5x over y squared. And this is all going to be raised to the second power. Okay, so first of all, let's look at what's going to happen with our signs. Okay, so I do have a negative quotient raised to the second power. That means this entire thing is going to be positive. Okay, when you have a negative in parentheses with an even exponent, you get a positive product. So we know that it's going to be positive. Now let's bring that exponent of 2 into all of the different pieces of this quotient. So I'm going to get 5 squared, x squared all over y squared squared. So let's see, 5 squared is 25. X squared is just x squared. But then in the denominator, we have y squared quantity squared. So anytime you have a single term in exponential notation that is then raised to an extra power, you keep the original base and you multiply your exponents. And there we have it. Our final product here, or our final quotient rather, would be positive 25 x to the second, y to the fourth. So let's just keep looking at examples here. Next up, I have negative 2 x to the third over 3 y to the second. All of this is going to be raised to the third power. Okay, so first of all, I have a negative, and then I have an odd exponent. So when you have a negative inside parentheses with an odd exponent, that's going to make everything negative. So let's just kind of deal with that first. So I've got a negative something, and that something is going to be 2 to the third, x to the third, 3 to the third, and then y squared to the third. So I brought that exponent of 3 from the outside into all 4 pieces of this quotient. So I'm going to carry that negative through. 2 to the third is 8. X to the third, we have a power rule, so I'm going to multiply my exponents. 3 to the third is 27, and then I'm going to get y to the sixth. Again, I'm going to multiply my exponents, okay? Next up, let's say that we have, how about this one? We have negative 3x squared y over 2z to the fifth quantity. We're going to cube everything, okay? So in this case, again, I have a negative inside parentheses. I have an odd exponent. That means this entire situation, this quotient is going to be negative. So now that I know everything's going to be negative, let's go ahead and bring that exponent of 3 inside. So I'm going to get 3 to the third, x squared to the third, y to the third, all over 2 to the third, z to the fifth to the third. So this is actually pretty similar to the last example because we have the same exponent, but let's carry over the negative. 3 to the third is 27. X to the third, or x squared to the third, is x to the sixth. Y to the third is just y to the third. Now 2 to the third is 8. Z to the fifth to the third is going to be z, and then I multiply those exponents to get 15. And there we have it. It's kind of fun. Let's say for this one, I have negative x to the fifth over y to the seventh, and I've raised everything to the sixth power. So again, I have a negative inside parentheses, but this time I have an even exponent. My exponent's 6, so that tells me everything is going to be positive, okay? So we know we're going to have a positive quotient here, so I'm going to bring that exponent inside. So x to the fifth to the sixth power is going to be x to the 5 times 6, or 30th power. Y to the seventh times the 6, y to the seventh raised to the sixth power is going to be y to the 7 times 6, or y to the 42nd power. And that's it. Let's do one more. How about I have 4x squared y over z to the fifth, all of that raised to the fourth power. Luckily, we don't have a negative to contend with, so we can just jump straight to simplifying. So I'm going to bring this exponent of 4 inside. So I get 4 to the fourth, x squared to the fourth, y to the fourth, and then z to the fifth to the fourth. So we want to simplify everything. 4 to the fourth might be something you don't know yet, but it is 256. X squared to the fourth power is going to be x to the 2 times 4 power, or x to the 8th. Y to the fourth is just plain old y to the fourth. And then z to the fifth raised to the fourth power is going to be z to the 5 times 4, or z to the 20th power. And that's it. Kind of fun. I don't think it's too bad. The next thing I want to show you is a little bit weirder. It's not something you see quite as often, and so you could do this next rule kind of the long way, but I am going to show you the shortcut rule. Next up, we have quotient to a negative power. So you would have a quotient like a over b, but this time it would be to the negative exponent. So what ends up happening here is it flips your quotient and then makes the exponent positive. So then you would end up just getting b to the n over a to the n. Why does this happen? Well, if I had a over b to the negative n, and I went ahead and just brought that negative power inside, I would end up getting a to the negative n over b to the negative n. And hopefully you remember, if we go back to that first screen, we talked about negative exponents right here. And basically, when you have a negative exponent, the term that contains the negative exponent goes to the opposite side of the fraction. So a to the negative n is going to go to a denominator. B to the negative n is going to go to a numerator. So we end up getting b to the n over a to the n, okay? But you can skip all of this. You can skip this process and just jump straight to the fact that your quotient's going to flip upside down, and that's going to make your exponent positive, okay? So let's look at examples. So first up, I have x over 3 to the negative 2 power. Well, I know that that negative exponent is just going to flip my entire quotient. It flips your entire quotient only when you have a quotient in parentheses with a negative exponent. But when I flip, it makes the exponent positive. So I really just have 3 squared over x squared, or 9 over x squared. So it's easy to use, but just make sure you understand when to flip the entire quotient. So next up, let's say I have 2 to the 5th raised to the negative 3rd power. So that's going to be 5 halves raised to the positive 3rd power, or 5 to the 3rd over 2 to the 3rd. 5 to the 3rd is one that's going to show up a lot, so you'll end up memorizing that 5 to the 3rd is 125. 2 to the 3rd is 8. Okay, now let's say that we'll do another easy one. 5 over 4 to the negative 2 power. Well, I flip my quotient, and then I make my exponent positive. So I end up with 4 squared over 5 squared, or 16/25. Next up, we have y over x squared raised to the negative 4th power. When you have a quotient in parentheses and the outside exponent is negative, don't forget you flip the entire quotient. So I get x squared over y. That makes the exponent positive. So I get x squared to the 4th over y to the 4th. X squared to the 4th is a power rule. So I'm going to keep the original base x. I'm going to multiply my exponents. And then y to the 4th is just y to the 4th. Let me get a sip of water before we do another one. Okay, let's say for this one I have x to the 3rd over y squared raised to the negative 5th power. So I flip my entire quotient, and then that makes the exponent positive on the outside. I bring that exponent in, I get y squared to the 5th over x to the 3rd to the 5th. Well, I've got 2 power rules. I'm going to keep the y, and I'm going to multiply its exponents. I'm going to keep the x. Let me rewrite that a little bit. There. I'm going to keep the x and multiply its exponents. So I end up with y to the 10th over x to the 15th. Next up, let's say that we have negative 5 over 3x squared raised to the negative 3rd power. I'm going to flip my quotient. I get 3x squared over 5. And remember, the whole thing is negative. And when I do that, flip, it makes my outside exponent positive. Now, let's talk about the signs. I've got a negative inside parentheses with an odd exponent. That means this entire quotient is going to end up being negative. The negative inside parentheses with the odd exponent makes everything negative. Now I'm going to bring the outside exponent in. And I'm going to make sure I bring that negative with me to my final answer. 3 to the 3rd is 27. X squared to the 3rd is really just x to the 2 times 3. And then 5 to the 3rd is 125. And that's it. So it's Not too bad. You don't see the negative exponent outside the set of parentheses too often, but I definitely want you to know how it works. And so what I want to do now is kind of expand this idea. We're going to do some more examples that are a little more complicated. So for this example, we have 5x squared y to the negative third raised to the negative 2 power. So on the surface, this very much looks just like a product to a power. You've got a product inside parentheses, you've got a power, okay? What you could do is you could bring that negative exponent into each of your factors. Or what I like to do is I like to simplify inside the parentheses completely first. So what I notice inside the parentheses is I have a negative exponent. So my 5 and my x squared are fine where they're at, but y to the negative third has to move to a denominator. So again, I like to simplify what's inside parentheses as much as I can first, and then I worry about those exponents that are on the outside. So now I have a negative exponent on the outside. So that's going to tell me to flip my quotient. Makes my exponent positive. And once I have everything inside parentheses simplified, the outside exponents are positive, then I bring the exponent into my quotient. So this is going to be y cubed squared over 5 squared and then x squared squared. Well, y cubed squared is just y to the 6th. 5 squared is 25. X squared squared is x to the 4th. And that's it. Okay, let's try another one kind of like that. And for this one, I have negative 2 x squared y to the negative 5th z to the negative 2nd, all of that raised to the negative 4th power. Kind of a lot going on here. But again, like I did in this first example on this slide, I like to simplify what's inside the parentheses first. You don't have to, that's just how I prefer to approach it. So my negative 2 and my x squared, they are perfectly content exactly where they're at. However, the y and the z term, they have those negative exponents. They need to move to a denominator. So I'm going to rewrite this as negative 2x squared over y to the 5th times z to the 2nd. And then I'll worry about that negative exponent on the outside. So again, for me personally, I like to approach what's inside the parentheses, simplify it first, then worry about the outside exponent. So outside exponent is negative. That's going to flip my entire quotient. And it's going to make my outside exponent positive. Okay, now let's talk about signs. I have a negative inside parentheses, but I do have an even exponent. That means this entire quotient is just going to end up being positive. So now that I know everything's positive, let's bring the exponent inside. So I get y to the 5th to the 4th, z squared to the 4th, 2 to the 4th, and then x squared to the 4th. If I simplify, y to the 5th raised to the 4th is really just y to the 5 times 4, or y to the 20th. Z to the 2nd raised to the 4th is going to be z to the 2 times 4, or z to the 8th. 2 to the 4th is 16. And then x squared to the 4th is really just x to the 2 times 4, or x to the 8th. And that's your final simplified answer. For these problems, sometimes it's hard to see what you need to do to simplify, but the good rule of thumb is everything is simplified when you have a single term of each type of base and all of your exponents are positive, okay? Let's do 2 more like this and then we'll wrap up this video. So for this one, I have 2xy to the negative 3rd over 7x to the negative 1st, all of that raised to the negative 2nd power. So like I've told you before, I like to simplify everything inside parentheses first, okay? So inside parentheses, I have an x and a y that need to switch places. So the 2x in the numerator stays, but then I'm going to bring that x to the negative 1st up. And then the 7 in the denominator stays, but I'm going to bring y to the negative 3rd down. Now, I've got 2 x terms inside parentheses, so I want to simplify that. So in the numerator, I really just have 2x squared over 7y to the 3rd. So at this point, I would be pretty content to go ahead and flip my quotient so that my outside exponent can become positive. Then I would bring that exponent into each part of this quotient. So I get 7 squared, x cubed squared, 2 squared, and then x squared squared. And actually, I have a tiny mistake. In the numerator here, it's really a y. Let me fix that. Okay. So then I just need to simplify everything and I'll have my final result. 7 squared is really just 49. Y to the third squared is y to the 3 times 2, or y to the 6th. 2 squared is 4. And then x squared squared is really x to the 2 times 2, or x to the 4th. Not too bad. All right. So these problems can be so frustrating because it's like, what do I do? What do I do? Just do something. Put the pencil to the paper and try something. Okay. Sometimes trying something isn't going to work. No big deal. Try something else. Okay. But if you follow the steps that I take, you're going to get the final answer. You might see something that's going to be a little quicker. That's great. Just show your steps. Don't try to do 5 things in your head at once. Write down each step as you do it. Keep track of everything. Okay. Because you could lose just a simple exponent and then the whole thing is wrong. So be neat, organized, write down your steps, and most importantly, just try something. Okay. So for our last example for this video, we're going to look at 36 x to the negative third y over 30 x y to the negative second. That entire quantity is going to be raised to the negative second power. So again, what I like to do is I like to simplify what's inside. And one of the first things I see is the 36 and the 30. They have a 6 in common. So 36 divided by 6 is 6. 30 divided by 6 is 5. So keep that in mind first. I also have x's and y's that have negative exponents that need to be simplified. So let's start. So I have 6 and a y in the numerator that are fine. Okay, sorry about that. Somebody joined me on Zoom, and so I had to pause the video. Okay, so basically what's happening here is we started out with 36 x to the negative third y over 30 x y to the negative second, all of that raised to the negative second power. What I did first was I reduced 36 and 30. Okay, 36 and 30 both had a factor of 6. I divided each by 6, and it simplifies down to 6 and 5. Okay. So what I'm doing now is I'm cleaning up this quotient inside parentheses. So in the numerator, 6 and y are going to stay put. In the denominator, 5 and x are going to stay put. Now from the numerator, x to the negative third needs to move to the denominator. Y to the negative second needs to move to the numerator. And what I want to do now is clean up that quotient again. I can combine those y's in the numerator and the x's in the denominator. So my numerator is really 6y to the third. What I did was apply the product rule. If I have 2 things that have the same base, like y times y squared, you keep the base and you add the exponents. Then in the denominator, I'm going to do the same thing. I have x times x to the third. Well, that's really just going to be x to the 1 plus 3, or x to the 4th. So what I have now is 6y to the third over 5x to the 4th, all raised to the negative 2 power. So at this point, I'm going to deal with that negative exponent on the outside. And the way we deal with that is we flip the entire quotient. Now, you flip the entire quotient only when you have everything in parentheses with a negative exponent outside. So flipping that quotient makes the exponent positive, and now I can bring that exponent of 2 into all 4 of these factors that make up this quotient. So I get 5 squared, x to the 4th squared, all over 6 squared, y to the 3rd squared. And then I simplify and I'll be done. 5 squared is 25. X to the 4th squared is x to the 4 times 2, or x to the 8. 6 squared is 36. And then y to the 3rd cubed is y to the 3 times 3, or y to the 9th. And that's it. So just a quick recap. We reminded ourselves of what we already knew from the previous video. We already knew the product rule. That means if you're multiplying 2 terms that have the same base, you keep the base, you add the exponents. The quotient rule is when you're dividing 2 terms that have the same base, you keep the base, you subtract the exponents. And then we had the power rule, which is the one we probably use the most in this video. The power rule occurs when you have a single term in exponential notation raised to a second power. You keep the initial base, you add the exponents. Now, the zero exponent did not show up in this video, but the zero exponent just says if anything is raised to the zero power, it equals 1. And then finally, from the previous video, we looked at negative exponents. And so if you have a to the negative n, you would rewrite that as 1 over a to the n. Or if you had 1 over a to the negative n, you would rewrite that as plain old a to the n. So basically, in short, what happens with the negative exponent is anytime you have a term with a negative exponent, it moves to the opposite side of the fraction, okay? Now, for the new rules that we learned in this video, we talked about the product to a power rule. So when you have a product raised to a power, so you have an entire product in parentheses raised to a power, that power comes into each factor of the product. We looked at lots of examples. And then we even looked at a couple of examples where we expanded what we already knew. We took a couple of terms and then we multiplied those. Next up, we talked about the quotient to a power rule. So the quotient to a power rule just means if you have a quotient in parentheses with a power on the outside of the parentheses, you can bring that power into each factor or each piece of the quotient. We did lots of examples of that. And then we looked at the quotient to a negative power, and the quotient to a negative power is a little different. So basically what happens is if you have a quotient in parentheses with a negative exponent on the outside, you flip your entire quotient, that makes the exponent positive, and then you can just apply the regular quotient to a power. We looked at lots of examples of that. And then we started looking at some just more involved kind of higher level examples. So we did the last 2 screens on that. Again, sorry about the interruption where I had that weird awkward pause. I paused the video because somebody joined me on my laptop Zoom. Okay, so that's it for these rules right now. So far we've got 3 videos on exponents and polynomials. The first video was just exponential notation. The second video we started looking at laws of exponents, and in this video we just continued looking at more laws of exponents. The next video that I'll make will be scientific notation because some of these laws of exponents come into play. And then after that, we're going to start looking at polynomials. So what is a polynomial, how to add them, multiply them, subtract them, divide them, the whole bit. All right. So for now, best of luck.